Assalamualaikum and good day to all students. My name is Dr. Intan Sharhida Uthman from the Faculty of Manufacturing Engineering, UTAM. Today, we will learn about Chapter 8. This Chapter 8 is on the characteristics, processing, and the applications of metals and alloys. This chapter is divided into 3 parts based on the learning objectives of this chapter. Before we start with this chapter, I hope you still remember the knowledge of the previous chapter, which is on Chapter 7. Chapter 7 is on the phase diagram. Please remember the knowledge, especially on the iron, carbon phase diagram, because in this chapter, we are going to use some of the knowledge regarding on the iron carbide phase diagram. As always reminded by all lecturers in the previous lectures, there are 3 course learning outcomes for this chapter. For this subject, the course learning outcome is to describe the processing methods for engineering materials. And in this chapter, we will only focusing on the metals and its alloys. Okay, from the taxonomy bloom, the verb described in the learning outcomes for this chapter is in the level of application, where the student needs to use and apply the knowledge, use problem-solving methods, manipulating, designing, and experimenting in order to solve any issues or problems regarding this Chapter 8. There are 3 learning objectives for this chapter. The first one is to differentiate between ferrous and non-ferrous alloys, and also its application. The second one is to describe a few common fabrication techniques for metals and alloys. And the third one is to describe the heat treatment process in order to improve the mechanical properties of metals and alloys. In order to have a good understanding about this chapter, you may ask yourself some questions. Okay, the first one is you may ask yourself on how are metals alloys classified and how are they used. The second question or issue that you can ask yourself is, what are the common fabrication techniques for metals and alloys? And how do properties vary throughout a piece of material that had been quenched, for example? And the last question that you can ask yourself is, how can properties of the alloy be modified by post-heat treatment process. Okay, this is the chapter outlines. Yeah, 8.1 is on the introduction, 8.2 is on the ferrous alloys, 8.3 is on the non-ferrous alloys. These three subtopics will be taught in the first part of this lecture. In the first part of this chapter. Okay, and for the 8.4 on the thermal processing of metals and alloys will be taught in the second part of the chapter 8. And the last one is on the fabrication of metals and alloys. It will be taught in the part 3 of this chapter. Okay, let's move to the introduction. I would like to give you one example of the real engineering disaster. This example will show to you how the metals and alloys changes in the properties due to the heat. This is World Trade Center, WTC in New York. The two towers of this WTC were designed involved structural steel, which can resist the lateral loading of 13,000 tons of wind pressure. However, in September 11, 2001, these two towers were collapsed due to the impact of aircraft. From the investigation, engineers believe that upon impact, the explosion blew away all the insulation that had been sprayed onto the steel floor trusses. The heat of the fires from the jet fuel weakened but did not melt the structural steel. The structural steel softened from the intense heat and the trusses collapsed. And it took only 11 seconds for the two towers to come down. From the failure analysis of the WTC components, the engineers found that the microstructure of the steel has been altered due to the heat from the explosion and resulted on the collapse of the WTC towers. Therefore, this chapter will introduce you to the structure, processing, properties, and the application of metals and alloys. Okay, let me ask you one simple question. What is a metal? A metal is shiny. A metal is malleable. Malleable is the ability of the material to be bent, flattened, or hammered without breaking. The metal is ductile. Meaning that the metal can be pulled into a thin wires without breaking the metal. Metal can conduct heat and metal can conduct electricity. Did you know that metal and its alloys can be classified into several different types? Here you can see several different types of metals. Okay, for your information, metals, alloys can be divided into two big groups. One is ferrous alloys and another one is non-ferrous alloys. What is ferrous alloys? Ferrous alloys are alloys based on iron, alloys based on ferrum, while non-ferrous alloys are alloys based on other materials, other metals. Okay, for example, non-ferrous alloys can be divided into few groups. Copper and its alloys, aluminium alloys, magnesium alloys, and also titanium alloys. For the ferrous, it can also be divided into another two groups. One is steel. Another group is cast iron. What is the difference between these two groups? The difference is in terms of the percent of carbon. For steel, the percent of carbon is less than 1.4% carbon. Meaning that this is the region of steel. Okay, and for the cast iron, okay, the percent of carbon is in between 3 to 4.5% carbon. So this is cast iron. And as I said earlier, in this chapter, you need to have the knowledge of the previous chapter. Okay, so this is the iron carbon phase diagram. Iron carbon phase diagram. It's a phase diagram for steel and also cast iron. Now, let's learn in details about ferrous alloys. Ferrous alloys are alloys those of which iron is the prime constituent. Okay, these alloys are important as engineering construction materials. About 90% of world's production of metals is contributed by this ferrous alloy because of their combination of good strength, good toughness, and good ductility. While the non-ferrous alloys are alloys that contains no or very little ferrum. But why ferrous alloys are popular? Okay, there are three reasons why ferrous alloys are popular. The first one is because iron containing compound exists in abundant quantities within Earth's crust. Okay, here you can see the picture of iron ore mining. And the second reason is metallic iron and steel alloys may be produced using an economical extraction, refining, alloying, and fabrication techniques. Okay, here you can see the steel extraction plant. Yeah? And the third reason is because ferrous alloys are versatile. Yeah? It may be tailored to have a wide range of mechanical and physical properties. Okay, this is the general flow diagram. Okay, general flow diagram of iron and steel making process. Okay, there are a few processes here. The first one is the iron making process. The second one is the steel making process, then followed by the continuous casting process, and then followed by the rolling process. For this iron making process, this process begins by mixing all the minerals such as iron ore, coke, limestone into a blast furnace. Then the chemical reaction in the blast furnace will produce a molten iron. Okay, next, this molten iron will be mixed with metal scrap. Okay, in the basic oxygen furnace or electric arc furnace. Okay, from this process, it will produce a molten steel. Then, this molten steel is transferred to a long, this molten metal. Okay, from here, it is transferred to the next process, which is on the continuous casting process, where this molten metal is transferred to a long open base mold to produce different shapes of semi-finished steel products, okay, such as billet, blue, and slab. Okay, here, this picture at the bottom, from this picture, you can see how the molten metals has been poured into the long mold. The orange color here represent the molten steel. Okay, then the semi-finished steel products are sent to the next factories for the rolling process in order to produce the final products of steel. Okay, in the rolling process, the semi-finished product of steel will go through several process such as section mill in order to produce rail sheet pile, shape bar, and then from the wire rod mill factory, it will produce wire rod, plate mill, it will produce plate product, hot mill, will produce hot roll coil and sheet, okay, and then cold rolling tender mill will produce cold roll or coil and sheet, and then welded pipe mill will produce welded pipe, seamless pipe will produce seamless pipe. Okay, here you can see this is the rolling process. The metal the metal go through two rollers in order to reduce the thickness of the metals. Okay, this is the image of a blast furnace. Yeah? This is the blast furnace. Okay, blast furnace is a type of metallurgical furnace which is used for smelting. Yeah? Smelting. Okay, in order to produce the industrial metals. Yeah? For example, yeah, in order to produce the pig iron. In the blast furnace, yeah, in the blast furnace, coke, limestone, and iron ores are continuously supplied to the top, eh, to the top of the blast furnace. While a hot blast of air is blown into the lower section of the blast furnace so that the chemical reaction in the blast furnace will take place throughout the furnace. Okay, here you can see, yeah, these are the reaction of iron reduction. Okay, this is the reaction of iron reduction. Yeah, from the process, yeah, there are two products. Yeah, one is slag and another one is the molten iron. Okay, the molten iron will then mix with metal scrap in order to produce the molten steel. Okay, and then after that, this molten steel will be cast into several steel product. Okay. Okay, this is the application of iron and steel. In this picture, you can see that the ferrous alloys, right, iron and steel, is used for making gears. Okay, gears. And the choice of the gear metal and its manufacturing depends on the size, stresses, power requirements, and environment in which they will be operated. Okay, other than gears, steel also, non-ferrous metal also, ferrous alloys also, are used for making structural component for construction industries. Okay, you can see ferrous alloys are used for making the structure for bridge, okay, stadium, towers, house. Okay, then ferrous alloys also used for making the component in vehicle, for transport industries. Then it also used in engineering purposes, for making the heavy duty vehicle, okay, and then for making the component for machineries, and then for making the structure for the telecommunication tower and others. And Ferrous alloy is also used for food and drink packaging, and also used in other markets and application as what you can see in the slides. Okay, now let's look at the classification of ferrous alloys. As we know, metals alloys can be divided into ferrous and non-ferrous. In this subtopic, we will focus on the classification scheme for the ferrous alloys. These ferrous alloys is divided into steel and cast iron. There are several types of groups under both steels and cast iron. Okay, let's look at steel. Okay, steel can be divided into alloy or plain carbon steel and high alloy. There are another three groups of low or plain carbon steel. Yeah? There are low carbon steel, medium carbon steel, and high carbon steel. The difference between these three groups is the percent of carbon. For this low carbon steel, the percent of carbon is less than 0.25. And to make you have a better understanding, let's refer to the iron carbon phase diagram. Okay. Here, this is the axis of carbon. Okay. For the low carbon alloy, the carbon is less than 0.25. So it's somewhere around here. Okay, so this belongs to the low carbon. And then for the medium carbon steel, the range is between 0.25 to 0.6, which is somewhere around 0.25 to 0.6, somewhere around here. So this composition belongs to the medium carbon steel. And then for the high carbon steel, the percent of carbon is between 0.6 until 1.4. Okay, this belongs to the high carbon steel, meaning that the carbon steel having high percent of carbon compared to the low and medium carbon. And under these three groups, there are neither two types of alloy, two types of carbon steel. You can see here under these three groups, there is plain carbon steel, plain carbon steel, and plain carbon steel. Plain carbon steel meaning that the carbon steel just consists of ferrous, carbon, and small percentage of manganese. Okay, while for the high strength low alloy, heat treatable alloy, tool alloy consists of alloying elements. Okay, so these three consists of alloying element. Okay, And here we have low alloy and we have high alloy. High alloy meaning that the alloy consists of high percentage of the alloying element. Alloying element. Okay. Yeah, for example, stainless steel. Okay, how about the cast iron? Cast iron, yeah, there are several groups of cast iron: gray iron, ductile or nodular iron, white iron, malleable iron, and the compacted graphite iron. Okay, what are the difference between these 5 groups? Yeah, the difference is in the terms of the composition of the silicon, composition of the silicon, and also the heat treatment process. Okay, heat treatment process. Okay, in this subtopic, in this chapter, you need to know the definition of some of the types of steel. Okay, the first one is plain carbon steel. Plain carbon steel is a alloy of carbon and iron with 0.03% to 1.2% carbon. Okay, and 0.25 to 1% of manganese. That is only component in the plain carbon steel. Okay, for the low alloy steel, it contains about 1 to 4% of alloying element. Okay, for this plain carbon steel, without alloying elements. Okay, for the low alloy steel, it consists of small percentage of alloying elements in the range of 1 to 4. Okay, what are the examples of alloying elements that can be added to the steel? Okay, here is manganese, nickel, chromium, molybdenum, and tungsten. Okay, the modification of plain carbon steel, by doing the alloying process, is used in order to improve the properties of the alloy. Okay, next, look at the stainless steel. Stainless steel have an excellent corrosion resistance in many environments. It contains at least 12% of chromium because stainless steel is under the group of high alloy. Okay. And then how about the cast iron? Cast iron usually contain 2 to 4% carbon and 1 to 3% silicon. Okay, if you look at the iron carbon phase diagram here, you can see that more than 2% of carbon up to 4.5% of carbon. This belongs to the cast iron group. Okay, less than 2% of carbon, okay, it is steel. Okay, this cast iron intended to be cast into desired shape instead of being worked in the solid state. Yeah? The cast iron is very runny when it is molten and doesn't shrink much when it is solidifies. Okay, look at this slide, still on the classification of steel, but now we want to see the comparison in terms of the name, addition, and then application, and also some of the properties of the different carbon types. Okay, this is plain carbon or low carbon, a low alloy steel, and this is the high alloy steel. Under the plain carbon and low alloy steels, we have here the low carbon steel, medium carbon steel, and high carbon steel. Okay, low is referring to the percent of carbon. Low, medium, and high is referring to the percent of carbon. Okay, the first comparison here, we can see in terms of the name. We can see for each of the group, it has the plain carbon steel, plain carbon steel, meaning that the steel do not have any alloy element except the carbon and also small percentage of the manganese. Okay, addition, no. Addition meaning that, is there any addition of alloy element? Okay, for the plain, is no addition. Okay, and then for the high speed low alloy, there are some alloy elements added to the plain carbon steel. For this high strength low alloys, the alloy elements are chromium, vanadium, nickel, and molybdenum. Okay, for the heat treatable alloy under the medium carbon steel, the alloy elements are chromium, nickel, and molybdenum. Okay, for the high carbon steel, for the tool steel, the alloy elements are chromium, vanadium, molybdenum, and tungsten. Why tungsten? For the tool, we need to have a very high hardness. So that's why the tungsten has been added to the plain carbon steel of high carbon steel group. Okay, example here is referring to the designation. Or the label of the steel. Okay, for the plain carbon steel, it starts with 1, 0. You can see the comparison here. For the plain, all plain carbon start with 1, 0, 1, 0, and 1, 0. Okay. And for other groups like HS, high strength low alloys, heat treatable, and tool, start with 4,000 something. 4. We start with digit 4. Okay, after this we will look on how to read the designation of the steels. Okay, for the application, here you can see various application. And of course, for the high alloy steel here, the application is for high temperature application, turbines, and furnaces. For the tool, the application is for making drill bits, saws, and dies. And here you can see from low carbon to the high carbon steels, yeah, the strength is increasing. Yeah, the strength is increasing because of yeah, the high percent of carbon, and also because of the addition of the alloying elements. Okay, when the strength is increasing, of course, the ductility is decreasing. Yeah? And then, of course, when we add more carbon and also we add alloying element to the plain carbon steel, it will increase the cost of the material. Okay, now let's look at in details about the plain carbon steel, the type of carbon steel. Okay, the first one is low carbon steel. Yeah, this low carbon steel consists of less than 0.25% carbon. Okay, this steel is unresponsive to any heat treatment process. Yeah? So in order to strengthen the steel, we need to do a cold work process. Okay, the microstructure of this steel consists of ferrite and also pearlite. This low carbon steel, because it consists very low percent of carbon, this steel is soft and weak, but have outstanding ductility and toughness. Because of that, it is machinable and weldable. And because of it just consists of very low percent of carbon, it is less expensive to produce. So here you can see the application. Okay, in order to improve, this low carbon steel, we have the high strength low alloys. The short form is HSLA. It contains other alloying elements such as copper, vanadium, nickel, and molybdenum. This alloy possesses high strength than the plain low carbon steel. Okay, it can be strengthened by a heat treatment process. This alloy is ductile, formable, and machinable. And this alloy is more resistant to corrosion compared to the plain low carbon steels. Meaning that this alloy, is alloy which was created in order to improve the weakness, in order to improve the low carbon steel. Okay, next we have the medium carbon steel. Consists of 0.25 until 0.60% carbon. May be heat treated by several heat treatment processes, for example, austenizing, quenching, and also tempering, in order to improve the mechanical properties. What are the alloying elements for this medium carbon steel? The alloying elements are chromium, nickel, and molybdenum. In order to improve the capacity of these alloys to be heat treated, giving rise to a variety of strength ductility combination. This steel is stronger than the low carbon steel. So this is the application. And here we have the third group, which is the high carbon steel. Consists of high percent of carbon. Okay, hardest, strongest, less ductile. Okay, it used as a two steels. Okay, which containing alloying elements such as chromium, vanadium, tungsten, and molybdenum. Okay, these alloying elements combine with carbon to form very hard and wear-resistant carbide compounds. Yeah? That's why these types of carbon steel is suitable to be used as a material for making knives, razors, spring, and high-strength wire. Okay, this is about the classification of plain carbon steel, or we call it also as the designation. The designation of the plain carbon steel. This classification or designation by 4-digit AISI SAE code, which referring to the American Iron and Steel Institute and SAE Institute. Okay, for this designation, it consists of 4 digits. Okay, 1, 2, 3, 4. Okay, for the first 2 digits, okay, is referring to the type of material. Okay, and another 2 digit, which is the last 2 digit, is represent the amount of carbon present in the steel. Okay, first 2 digits are 10, which indicate the steel is a plain carbon steel, while the last 2 digits indicate the carbon content of carbon content of the steel. For example, here for the classification of 1030 steel, indicate a plain carbon steel. How do you know that this is plain carbon steel? By referring to the first 2 digits here, 10. And this plain carbon steel is containing 0.30 weight percent carbon. How do you know this? Is by looking at the second last digit, 30. This 30 is represent the 0.30 weight percent carbon. Okay. Okay, as carbon content increase, steel becomes stronger and less ductile. Okay, all plain carbon steel contain manganese range between 0.3 to 0.95%. For medium carbon steel, for example, the designation or classification is 1020 until 1040. Okay. For the high carbon steel, the designation is from 1060 to 1095. Okay, this table is about the mechanical properties of plain carbon steel. Plain carbon steel meaning that it just consists of carbon and also small percentage of manganese. Okay, this column is about the IC number, AISI number or designation. Yeah. So this table is about the plain current steel, as what you can see here. All numbers starts with 10, yeah, 1010, yeah, which indicate plain current steel. Okay, this is the chemical composition, where you can see here, yeah, it just consists of carbon and small percent of manganese. Okay, this another last two digit, yeah, yeah, is referring to the chemical composition of the steel. Okay, make sure you know how to read the um, number, the IC number. Okay, so in the next column is about the properties and also application. And what you can see here, just look at the megapascal unit. Okay, what you can see here, the number, the properties or value of the tensile strength is increasing. Yeah, is increasing as the percent of carbon increase from 0.1 to 0.95% carbon. Okay. Okay, what is the limitation of plain carbon steel? There are three limitations. One is low corrosion, okay, and oxidation, low corrosion and oxidation resistance, okay, cannot be strengthened beyond 690 megapascal without losing ductility and impact strength, and poor impact resistance at low temperature. Okay, so how to improve the properties of this plain carbon steel? Okay, let's think what is the answer.